Let's now look at the difference between a virtual machine and Dockers. Virtual machine is about a decade old when actual physical machines was made into a virtual machine. Physical machine meaning the on-premises based. You get a server and then make it into a virtual machine in your own data center or in your own for a particular organization. Virtualization was performed. But later on, I think about 5 to 7 years before, right from 2013 is what virtualization was taken to cloud, and you were able to get virtual machines on the cloud. And about 5 years back, we started hearing about Dockers. The virtual machine itself was to ensure that there is cost-effective solution, there is optimizations are happening. Because of that, people went for virtualization. Instead of having a one big physical machine just for one specific application, they went for virtual machine. Dockers is even a step forward, and that is where from virtual machine we are getting into the Dockers and Kubernetes as well. So we look at the difference between a virtual machine and Docker. So this is a kind of a comparison in case of a virtual machine and a Docker. You have a host operating system, and then you have a hypervisor which monitors the different operating systems. Like maybe you have in a single physical machine, you might have a Windows, you might have a Linux, Unix, and then you have the necessary applications in case of virtual machine. But in case of the Dockers, yes, in case of Dockers, it is independent of the hypervisor. So main concept is bins or libs is what we call as containers, and then you have apps. The apps, in case it is called the images, and bins is called the containers. Apps are called the images, and you need to, from the application, you need to create the images using the Dockers. So Docker is a tool designed to make it easier to create, deploy, run application by using containers. Containers allows developers to package up the application with all part it needs. You have seen a situation wherein, you have a piece of software code, same code, it runs in one machine, it doesn't run in same configuration of another machine. So there could be dependencies, configuration setup, libraries not included. So those challenges are there. So that is where when you use Dockers, all the dependencies are all packed together so that whether you run it on machine A or you run it in machine B, it will run effectively or without any hiccups. It will run in both the machine because all the interdependencies are put inside the container that as an image file. So it will run irrespective of the machines. So by doing or performing containerization, developer can be rest assured that application will run on any machines regardless of any customized settings. That is where it is critical as far as the Dockers is concerned. The customized, it is independent of the customized settings. So by performing containerization, the developers are assured that application will run on machine regardless of any customized setting. The key difference. So if you look at it, virtual machines requires hypervisor to monitor, to create virtual machine, whereas in this case it interacts with the operating system. Operating system contains kernel, so it interacts with the kernel. In case of virtual machine, bigger footprints, because while creating, yes, you can assign the storage space, secondary storage space, RAM and all, but once you're assigned it, yes, you got to drop the virtual machine, recreate it. But whereas Dockers, independent of the hardware. So that's where it is called the small footprint. So this one, again, we have already seen about the hypervisor, needs hypervisor, interacts with kernel. Deployment is tough, whereas deployment is easier. But as we progress, you will understand it more, the advantages of having Dockers over the virtual machine. So thank you, stay tuned. So having seen about Dockers, let's now compare with the Kubernetes. I would say Kubernetes is much more flexible and it has all the features of Dockers as well. So Kubernetes is a portable, extensive open source platform for managing containerized workloads and services that facilitate both declarative configuration and automation. That's the definition. So it's an open source platform for managing containerized workloads. So it's basically orchestration of containers. So it is very large, rapidly growing ecosystem. Kubernetes services supports tools are widely available. So as application grows, you have multiple containers. So if the application is very small, you have an just one image, then yes, it's possible. You build the image and then you run the application. We saw that with just Dockers with an example like hello from Dockers, or we had a Python code, and then we had built an image with the Python and then just ran that. So this is just for single container. But what if if it is a complex application and multiple developers are being used, you have multiple containers and it is spread across multiple physical machines, or it could be spread across a virtual machine. That is where Kubernetes is being widely used. So managing them, that's where Kubernetes cluster orchestrates cluster of virtual machines and schedules containers to run those virtual machines based on available compute resource and the resource requirement of each containers. So you can scale up, basically you can scale up or scale down the number of, because it's all virtual machines. When it is used, you can always, depending upon the load, the workload, you can scale up, add additional nodes, you can reduce those nodes. So containers, again, if you look at the containers, and containers are grouped into pods, the basic operational unit of Kubernetes, and those pods scale up to a desired state. Kubernetes also automatically manages service delivery, incorporates load balancing, tracks resource allocation, and scales based on compute utilization. So in case if there is a requirement, the program requires more nodes, then nodes gets allocated, and it also can get deallocated as well if the resources are not required. So this is the cluster diagram. If you look at it, this is a cluster diagram where you have nodes, and then you'll have a scheduler for control of those nodes. This diagram will give you in detail. So there are nodes and different nodes. There is a container. Under container, what do we have? So under container, you'll have the image, which is basically, you can call it as a kind of a program unit, and that is what is referred as the pod. And pod with the kube proxy is called the node. You have 3 nodes over here, and cloud controller, cloud scheduler, and this is called the Kubernetes master, which needs to control the nodes using the cloud controller manager and kube scheduler. So this is a kind of a pictorial representation. You have nodes, and you have a Kubernetes master which controls the nodes through the controller manager and the scheduler. So terms, I mean, there are commonly referred terms. One is the cluster. Kubernetes cluster, it's always called as Kubernetes cluster, is a set of machines individually referred as to nodes that used to run containerized application managed by Kubernetes. And then a node could be a virtual machine or a physical machine. A cluster consists of master node and number of worker node. So the master node is what is going to perform the scheduling activity. So basically node is a virtual or a physical machine. Then comes container, and containers has the images which could be custom built, or it could be image which is standard image which is being used in the container along with the necessary dependencies. So in a container you can have the Python binary for running any of the Python custom program. So that's the cloud container. And pods is a single container or a set of container running on the Kubernetes cluster. So then you have Deployment is an object that manages replicated application presented by pods, and pods are deployed on the nodes of the cluster. Replica set, specified number of pods replica which is running at one point of time. The reason is, suppose if one pod fails or something happens, then the other pod should take over and run that. So particularly if it's a pod replica set, to ensure that the application doesn't fail, you can have the replica set in place. Services, so that describes how to access application represented by set of pods. So services typically describes ports, load balancers that can be used to control internal or external cluster. So the terms, if you refer, critical ones are nodes, physical or virtual machine, and containers. Container contains images. Pod, it's a single container or a set of containers. Then you have deployment. Pods are deployed onto the nodes of the cluster, and replica set is how many replicas you want. And finally the services, how do you call them as an application? That is what is the services. So these terminologies will keep repeating again and again, and as we progress, and as you see an example, then it becomes much more easier to understand all about Kubernetes. Thank you. Let's quickly run through the differences between Kubernetes and Docker in a kind of a tabular format, so that the understanding is much more easier. So Docker's containers in isolated environment for applications. So you can have a program with maybe a multiple containers. It can run, it's fine. So that's for the Dockers. But here with Kubernetes, you can have multiple containers and nodes, meaning nodes being the virtual machines. So for managing them, you need Kubernetes. So automated building and deploying application. Here it is automated scheduling and management of application containers, particularly if it is across the nodes. And nodes, again, remember, it could be different virtual machines. Container platform for configuration, building and distributing container. Ecosystem for managing containers. Easier installation, and Kubernetes is quite complex installation. That is where, if you look at any of the cloud platforms, whether it is Azure, or if you're going to use Oracle Cloud Platform, they have a Kubernetes cluster in place, because there it is complex. Whereas Dockers, if you have a virtual machine, you can just go on and install Dockers. We saw them earlier, how easy to install Dockers on the virtual machine. So again, Dockers are lightweight, but limited functionality and easier to use, whereas Kubernetes, the learning curve is higher, powerful, but flexible as well. And then manual scaling supports auto scaling. As I said, if you want to add nodes, you can automatically do that through the through your initial configuration or through your programs. Auto scaling is possible with Kubernetes, whereas with Dockers it is manual scaling. Limited monitoring through Dockers a little dicey. You might need a third-party tool, whereas with Kubernetes, efficiently in the platform itself, you can from the cloud infrastructure itself, when they have Kubernetes cluster, you can efficiently or effectively monitor them. So similarities, again, there is something called as Docker Swarm, and Docker Swarm works on a YAML file, and Kubernetes is also similar. Auto scaling is what could be a little bit of a challenge with Docker Swarm. That is where it is always possible with Kubernetes, and that is where, as I said, it is all available in most of the standard cloud platform. So I think now you have a better understanding of the difference between Dockers and Kubernetes. Thank you.